All right, if we take a look at number 42 here, it's giving us two sets of numbers, and then it's asking us to identify the intersection of these two sets. Remember, we've got two symbols here. The one that they're displaying here, that's the intersection, which is essentially the overlap. It's what they have in common. The other question they could have asked us is the union of the two, which we just flip that symbol upside down. And that's when we take all of the elements from each set and combine them. But for this one, we're just looking for the intersection. So I'm looking for what they have in common. So I just go right down through this set. It looks like they have a 2 in common. It looks like they have a 4 in common. And I don't see anything else. So that means that the intersection of this set would be the set that contains 2 and 4. And that's it. Okay? It's the intersection we're looking for, what they have in common. For the next one, it says Lewis leaves home riding his bike. The graph below relates two quantities, distance from home and the time in minutes of Lewis's trip. And it wants us to use the graph to write a summary of essentially what Lewis did on his trip here. And it asks us to be sure to include a description of Lewis's relative speed during different intervals of the trip as modeled by the graph. So if we look at this this model, it's giving us the distance from home over here and then the time in minutes. Okay, so as the minutes progress, if his distance from home is increasing, that means he's traveling at some rate of speed. And since this is a linear equation, it means it's a constant rate of speed. Okay, so he starts off riding at a constant rate of speed. So he's riding at a constant rate of speed. So he's riding at a constant rate. And then what happens here is we know this thing kind of flatlines. And essentially what's happening here is the minutes are still increasing, but the distance is not increasing anymore. So if the minutes is still going, but his distance hasn't changed, it means he stopped to take a break. Okay, so this flatline piece here means he stopped to take a break. So he stopped. And then after his break, we see that the time and the distance once again begin increasing. But if we compare this, again, the time and distance are increasing, but now measuring the same unit of time, the distance is increasing by more than it did before. See, over here, it's going up 1 over 1 in terms of the slope. And then the second half of this is going up 2 over 1. So his distance is increasing more rapidly. So he's riding at a faster pace than he was before. So he continues riding, but this time at a faster rate. Okay? And you can be a little bit more descriptive and make use of full sentences here. But just to give you a general brief understanding of this, he's riding at a constant rate, he stops to take a break, and then he continues riding at a faster rate. Okay, that's what the graph tells us. If we look at the next one, it says, what is the solution of the absolute value of negative 2x plus 5 is less than 60? Remember, whenever we have absolute value equations or inequalities, we end up splitting these into two separate pieces. All right. With an inequality, it just gives us a compound inequality, either and or. And what we do is we write this exactly the way it was written without the absolute value sign. So no absolute value, such as negative 2x plus 5 is less than 60. But then we also do negative 2x plus 5. Forgot my x here. And instead of a positive 60, we make it a negative 60. And as soon as we change the sign of what's over there, we have to flip the inequality sign. So I'm going to change it to a greater than symbol. All right? And now essentially what I have is I have two separate inequalities to solve. When I look at this first one, I'm going to subtract the 5 from each side. So I get a negative 2x is less than, a positive 55. And now I've got to divide each side by a negative 2. And keep in mind, since this is in an equality, It's an inequality, which means when I multiply or divide by a negative, I have to flip the inequality sign, so now it's a greater than symbol. And this is going to be a negative. We can leave it as an improper fraction, which is a negative 55 over 2. If we wanted that as a mixed number, that might be helpful for graphing this. Or we could write it as a decimal. That would be fine also. Looks like a 27.5 or a negative 27.5. All right, I'm going to write it as a mixed number just for graphing purposes. And then over here, I got to do the same thing. I'm going to subtract the 55 from each side. So that's going to give me a negative 2x is greater than a negative 65. Again, I divide each side by a negative 2. And when I divide each side by a negative, I have to flip the inequality sign, so it becomes a less than symbol. Negative divided by negative is a positive, so it's 65 over 2. And again, for graphing purposes, I'm going to go ahead and write this as either a decimal or a mixed number. It looks like that's going to be a 32.5 or 32.5. And the reason I do that, and the reason I'm talking about graphing this thing, is because we're always going to have to graph this to check our solution. Because again, this is either an and or an or inequality. And if I look at the original problem, since the absolute value was less than, so it goes by this symbol right here. If the absolute value is less than, it's an and inequality. If the absolute value is greater than, it's an or inequality. And so I have to check this to make sure there's overlap. With and, I have to have overlap. So if I've got a positive 32.5 up here somewhere, and a negative 27.5 down here somewhere, the first thing tells me I want to be greater than the negative 27.5. So that would be everything from here up. And then the second piece of this tells me I want to be less than the 32, and we can see where they're going to overlap. They're going to overlap in between these things. And when I'm talking about an and inequality, I only want the overlap. And that's why I draw the graph. I draw the graph to check to make sure that my solution is valid, to make sure that there's overlap. So now that I see it's valid, I can rewrite this as one string. It's I'm going to go back to the improper fractions, negative 55.5, less than x, less than the 65 halves. Okay, you could keep it as mixed numbers or as decimals. That would be fine. But when we have an and inequality, we can write it as one string. So that's my solution. Okay. In number 45, it says Joe started a new job in 2001, and his salary was $32,600 at the beginning of the year. At the beginning of the next year, he will receive a raise of $1,560. Assume he will receive the same raise every year. Write a function rule for finding Joe's salary after 2001. Find Joe's salary in 2007. All right. So essentially what we're doing here is we're going to call y his salary. So y equals his initial salary was the $32,600. And what happens is every year we're going to add to that total. So we're going to add another $1,560. Okay, but we're going to do that every year. So after 1 year, we would add $1,560 to that. After 2 years, we would double the amount we're going to add. So in other words, we would add the $3,120 after 3 years. And the point here is that we're multiplying this 1,560 by the number of years past his first year that we have. So we'll call that x, okay, is the number of years. So in other words, if I rewrite this, it's y equals 30, I'm going to rewrite it in a different order, 1,560x plus 32,600, okay? And that's the function rule we're going to look at here. In other words, this is his salary after X number of years, okay? And if we're talking about the number of years after 2001, if we want to find his salary in 2007, well, 1 year after his initial start, so 2002 would be 1 year, so that would be an X value of 1. 2003 would be 2 years after his initial start, okay? So 2007, we go 04, 05, 2007 is going to be the 6th year after he started, okay? And that's what we measured our X value in. is the 6 years after he started. So this is my rule. That's for part A. Part B, I just have to plug a 6 into this equation. So I'm going to do y equals 1,560 times 6 plus the 32,600. Okay, and I just have to plug this into my calculator. When I multiply times the 6, it gives me a 9,360. And then we just have to add that to the salary that he started at, which was the 32,600. So we find out that he is now making $41,960. Okay? And that answers part B. So again, we wrote the rule based on the number of years after he was hired. So we have to plug the X value in based on the number of years after he was hired. Okay? For the next one, it says, a boy that is 4 feet tall casts a shadow 6 feet long. He stands next to a monument that has a 32-foot long shadow. How tall is the monument? Okay, so we've got our boy here. I know I'm quite the artist. And he casts a shadow on the ground. And it says that the 4 foot tall boy, so the boy is 4 feet tall, casts a shadow that is 6 feet long. And now he's standing next to a monument. Yep, it's a monument to rectangles. And it says that the rectangular monument here casts a shadow that's 52 feet long. We want to find out how tall the monument is in feet. Okay, so essentially what I'm doing is I'm setting up a proportion here, and I can compare these things. I can compare the boy's shadow to the monument's shadow, the same way that I can compare the boy's height, the 4, to the monument's height, which is x. Okay, so I've set up a proportion between the height of each thing and the length of its shadow, and now I just have to cross multiply. So when I do the 52 times 4, it gives me a 208. When I do the 6 times x, it gives me a 6x. So now I'm going to divide each side by the 6. And I find out that x equals, and just be careful when you're doing this, it looks like it gives me a 34 2/3 feet. Okay, so 34 2/3 feet. If you plug it into a calculator, it's going to give you 34.6 repeating, which is 2/3. Okay?